Hey guys, how's it going? Welcome to the part 7 of Python Pandas tutorial series. In this video, we will see how you can add and delete a column using Pandas data frame object. So without any further delay, let's get started. So as you are aware of, you can treat data frames schematically like a dictionary, and you can get, set, and delete columns working with the same syntax analogous to the dictionary operation. So here what we have done, we have imported pandas and numpy, and here we have created a data frame with 4 columns, 4 rows and 2 columns. Now as a next step, we will see how you can insert a column. So when inserting a scalar value, it naturally propagate and fill the column. So let's look how you can add scalar value. So to create a new column, let's say column C, df, then I have to pass the column name within the square bracket, and then here I will just say equal to, or a sign operator, test, and this is the scalar value, one value. And because this pandas data frame object support broadcasting, it will just propagate to fill all the values of the series of a column. So now let's run this one, and also at the same time say print df. Now you can see the column C is being added at the end. Now you can also insert a row in the array, but their length must be matched with the length of the data frame index. So we can do that using, say, new column. And by the way, you can do it both by a raw numpy array or a simple list as well. So here we will see the example in the with a list. I'm creating a list which has 4 elements for random element. Then I'm going to insert this one to the data frame, and I will call this column as D, and then I have to just say assign new call, and here I will say print df. Now if I will just go ahead and run it, you see the column number, the column D is now being added at in the end. So in all the example you have seen, the column, when you inserted it, it actually add in the end or at the very last of the data frame, But you can also insert a column at a particular position, and you can do that by using insert function, and we will see the example here. So let's say we want to insert a column between A and B, and I will call it as A underscore N B. Okay, so between A and B. So for this one, what I will do, I will just say df, and then I will access this insert method, insert, and the first argument of the insert method is the index where you want to, the index of the column where you want to put your new column. So I want this column A and B to be inserted between A and B. So that means the index should be 1. The column index should be 1. And next argument would be the column name, which is A and B. And the third argument is the column itself. Okay, the value of the column itself. And for that, I will choose df a column, and whosever is greater than 5. So this will return a boolean value saying that true or false if it is greater than, if each element of the, it will test this theory on the each and every element of the column A, and if it is greater than 5 it will say true, if it is less than 5 it will say false. Now if I will just go ahead and run it, you see now the new column A and B is inserted within A and B, because we are using insert method and giving as index as a 1 as a first argument. That's why this operation happens. Now, inspired from the R's DP layer mutable verb, data frame has an assignment assign method that allow you to easily create a new column that are potentially derived from the existing column. And this assign method will always return a copy of data frame, okay, and leaving the original data frame untouched. So we will see the example here. Now here I will say df and dot assign, and then I will call the name of the column which I want to assign, and here I can mute it from the existing column, saying that df, this random operation I'm performing, df a column divided by df b column. Now if I will just show you print df, oops, something wrong. Okay, it's not AF but rather DF. Now if I will just go ahead and run it, you will see the data frame is not changed yet, because this particular assign method is actually return a copy. So if you want to assign, if you want to perform an addition of the column operation using assign method, then you have to assign it to data frame again. In that way, the new column E is being added in the end. Okay, and in this above example which we have seen, we have inserted a pre-computed value. We can also pass a function to one argument to be evaluated on the data frame being assigned to. So for that, let's see the example here, and we will call df is equal to df dot assign, and then here I will call um, let's say f, and then here's equal to lambda. So here I can define any function or one liner. In this example, x, it will take each item of xa and divided with the xb. Now if I will just go ahead and run it, and will show you print df, you can see the column f is being added at the end, and we have done the exact same thing what we have done previously, but using this lambda expression or this function, um, any Python function. Cool. Now let's see how you can delete a column. To delete a column, you can use a similar function, but you can first need to access the column which you want to delete. For example, I want to delete column A and B, which we have inserted between A and B, and at the beginning we have to specify del. It is very similar to delete or popped like dictionary. So first we will see delete method, which is similar to the dictionary element delete in that way. And also I will show you the new data frame. Now the column A and B, which used to be present between A and B, so now is being deleted. Similar to the dictionary popped operation, you can also perform uh, popped method in the data frame. So you can access df.pop, and then you say the column which you want to pop. The good thing about pop is that it will not only delete the column, but also it will delete the element or column in this case, but also it will return that element or the series in this case, which we can assign it to a value, a variable. So here I will say deleted equal to df dot e, and in the next line I will say print deleted. Now if I just go ahead and run it, you see this column which is being deleted, we grabbed it and put it in the variable deleted, and that's why we could able to access this one by using print command. Okay, so this is the difference between pop and delete. In pop, you not only delete the respective column, but also you could grab that entire series and you can also assign it to any variable. Okay, that's the very basics of how you can add and delete columns. If you have any question till now, please feel free to drop your questions comment in the comment section, or else thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.